we got to see that the AC source, the current and the voltage, they vary in this manner. So they keep changing every second. To analyze this particular graph per se and to visualize this, it's not so easy. Things are moving across. It's kind of an headache. So to help us better visualize and understand and discuss, right, we make use of something called as Phasor diagram. So this helps us in visualization. So that's what we are trying to understand. The word or what is Phasor diagram. So now we'll start off with the word Phasor. Phasor is to do with rotating vector. That is the vector which keeps going around a particular center. That represents a sinusoidal varying quantity. How does it represent? What is first of all sinusoidal? Yes, it is to do with sine wave. A smooth wave that looks like a sine. Okay, so that is sinusoidal varying quantity. So this will vary with time. Let me show this. Let me show Phasor first. So what we're looking at in the topmost rectangle square box is a vector whose magnitude is fixed, but it's rotating. So the vector keeps changing. How does it change? It's changing its angle. Now, how does it represent a sinusoidal wave? If I pick up the projection, right, you can see the projection. Let me show it exactly what I mean. If I pick up the projection of the vector onto the y-axis or the x-axis, here we generally deal with y-axis. This particular value, this projection, this projection, if we take up all the projection when it goes one complete round, right? If I take up all that value and plot it on a graph, we'll get a sine wave. Actually, we have done it over here. We have done that over here. You can see the bottom wave. It's not just randomly varying. It's picking up the projection, plotting on the right end. And since, if we keep plotting, of course, it has to continue, right? So we are kind of shifting the sheet to the left. We have to keep drawing, So technically, the bottom axis value also has to keep changing. I fixed it, but technically it needs to keep moving across. So it's like a live graph. I hope you guys got a bit of understanding of what is a Phasor. It's just a vector. This is the main vector. That's your Phasor. It's rotating, and this rotation is such that when we plot it, right, taking one of the factors, that is the projection of the vector onto the y-axis. Projection of the vector onto y-axis. So if I take up all the values, and it goes around the circle, around the point actually, around the point. If I pick up all the values and plot it on a time varying graph, you'll get a sine wave. Right, that's it, as simple as that. Now, how will we make use of this? Oh yeah, there is a few more things. We need to know about its length. A Phasor has its length. Length is proportional to the maximum value of the variable it represents. So basically, that is length. The standard solid line, red line, is your length. The dotted line is your projection. Angular speed, it is how fast it's going around a point. Projection of a Phasor onto a vertical axis represents the instantaneous value of the quantity it represents. So this is the instantaneous value. Instantaneous value. That is value at a particular point of time. Now, this idea we are continuing, and we are calling this as Phasor diagram. So what is it? It helps us visually represent the magnitude and phase relationship of interdependent functions which vary with time. So let me first thing first, let me show that. What does that mean? So here we have two phasors and they have the same omega t. They're rotating at the same pace. One of the value, one of the variable, one of the vector has a lot of length amplitude than the other. Next thing, there is the angular gap between them, right? That will keep happening. You can see that since the speed is same, that gap keep continuing. Why does that gap matter? All of that we'll understand in time, but you can see that there is a gap. To visually represent this particular scenario, if you put it on the graph, it's going to be a bit of headache. But just looking at this is quite simple, right? Does it make sense? And can you look at the projection of those vectors onto the y-axis? Let me show it over here. Can you see that? Those are the projection, right? Along the y-axis. So all of this helps us. How does it help? That's another thing. So all of this helps us. So that's what we are trying to learn over here. Now, what is the definition? A Phasor diagram is a graphical representation of magnitude and phase relationship between two or more sinusoidal quantity. Sinusoidal quantity means one which varies smoothly in that manner. Time varying function. And the variation is such that we can plot it on a graph and that graph looks like a sine wave. So what are the uses end of it? What are the uses? So we have this, what is this? I'm talking about Phasor diagram. The uses are that it is used to represent AC circuit analysis. It used to represent quite a few things in that, and it helps us analyze power system, control system, signal processing, communication system, so on and so forth. So in all of this, we'll make use of Phasor diagram. So actually, let me put up a diagram over here. It helps us understand things better. So it's not that we need to have different length. The amplitude need not be different. It can be same. So or it can be different. So here we have two vectors, two phasors, and we are making use of the projection onto the, let me change the color, to the y-axis, onto the y-axis, and so on and so forth. Sorry, my bad. Okay, so that will be your amplitude. That will be your instantaneous value of, say, your Phasor A, and this is Phasor B. These are your instantaneous value. B, Phasor B, and that's of Phasor A. Okay, so yeah, for now you guys can pause and have a look.